In this video, I discuss testing hypothesis for one main test when variance is known. This is very important because we do have two cases. First one is the variance is known. Second one, variance is unknown. Okay, here we follow the four steps. First one, read the problem and identify the null and alternative hypothesis. Null hypothesis H naught mu equal mu naught versus alternative hypothesis. We have HA, we have three options: mu not equal mu naught, which is called two-tail test or two-sided test, then mu less than mu naught, lower tail test, and one-sided. Last one, mu greater than mu naught, is also one-sided and upper tail test. Then number 2, decide on the significant level, which is alpha. Significant level should be given on the problem. Third one, find the test statistic. We use the z naught and x bar, which is sample mean, minus mu naught, which is this and h naught, mu value and h naught, sigma population mean divided by root n. N is the sample size. Then we find the p-value. So p-value depend on the alternative hypothesis. So part A, p-value for two-tail test. Actually, we find the p-value for the two-tail test. P-value equal 2 times probability z greater than or equal absolute value of z naught. And if this look like this is the normal curve. So two-sided, we consider this in the z naught, what is absolute negative, and z naught absolute value. So this area plus this area is the p-value. So p-value for the left tail test, if it is left tail, this graph should be this is the negative z naught, then this is the area we are looking for the p-value. So that this is the p-value. Therefore, p-value equal probability z less than or equal z naught. Okay, the last one, p-value for left tail test. Then graph should be the other way. This is the normal, this is the z naught. So this is the p-value we are looking for, that is the p-value. So p-value equal probability z greater than equal z naught. Okay, these are the 4 steps to find the testing the hypothesis. Now let me discuss this example. First, read the example. The Carolina Tobacco Company advertised that its best selling non filtered cigarettes contain at most 40 milligrams of nicotine. But Consumer Advocate magazine ran tests of 10 randomly selected cigarettes and found the amounts in milligrams. This is the sample they check. This is the sample they check. It is a serious matter to charge that the company advertising is wrong. So, the magazine editor chooses a significant level alpha equal 0.01 significant level. Can the editor prove that the mean nicotine level is greater than 40 milligram? Assuming nicotine levels are normally distributed and sigma equal 3.8. Okay, now write down the information we have. So, sigma is given, it means we know the variance. So, we can use the z test. And alpha is given 0.01. So, let me write down the first step, null and alternative hypothesis. So, what do we want to check over here? Say, can the editor prove that the mean nicotine level is greater than 40 milligram? It means mu equal 40 and greater than mean mu greater than 40. So here this is mu naught. Mu naught is 40. Then go to the second step. Actually alpha significant level is given. So 0.01. Third one, find the test statistic which is z naught equal x bar minus mu naught sigma over root n. Think we do know everything but x naught. How do we find the x naught? We do have a sample. We do know the sample values. What are those? 47.3 and add 39.3 plus this 46.3. You should add all the value from here to here. Then divided by number of data, we do have 10 data. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, you can use the calculator. So get the answer. Answer should be 43.30. So we can plug the numbers here. X bar 43.30 minus mu naught. Here we know 40 divided by sigma given 3.8 divided by root n, the sample size. Okay, this answer 2.746. Now we know the test statistic. Now we can find the p-value. Okay, before we find the p-value, go and check the null hypothesis. What is the null hypothesis? It is a lower tail test. No, I'm sorry, it is the upper tail test. It is the upper tail test and right tail test. So it should be this way. You have normal this. So this is the 2.746. I round it to 75. Therefore, this is the p-value. This is the p-value. 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 So p-value equal probability z greater than equal 2.75. Probability 2.75. Actually, we use the table z table. It gives the, if you check the graph at the top of the table, it gives the area from the left corner. Therefore, we cannot use the table directly for this. So we have to write down probability z less than equal 2.75. So now we can find the probability z less than equal 2.75. If you check the table, it gives the value 9970. So this answer should be 0.0030. Okay, now we follow the all steps. Now how do we get the decision? So that is the last step. So decision, we should compare p-value with alpha. P-value with alpha. So what is the p-value here? Our p-value equal, I say a p-value equal 0.0030 and alpha equal 0.01. So alpha is the greater. If alpha is greater than p-value, our decision is H0 is rejected. H0 is rejected. If p-value greater than alpha, then H0 is not rejected. So now we know p-value equals 0.0030 and alpha 0.01 is alpha. So again alpha greater than 0.001, which is alpha greater than p-value. So our decision is H0 is rejected. If H0 is rejected, what should be the conclusion? Okay, so let's write down the null hypothesis. Again, H0 mu equal 40 versus HA mu greater than 40. So our conclusion, our decision is H0 is rejected. H0 is rejected mean this H0, this value is not true. If this is not true, this should be the true. This should be true. It means mu greater than 40. It means our conclusion, the sample data support the claim that the mean level of nicotine is greater than 40.